There is a new strategic plan out through the ONF. ADTRAN became a supply chain partner earlier this year as part of this new strategic plan. So I guess the high-level summary of the strategic plan is, a lot of you guys have heard about Cord. It's been out doing different POCs and stuff for the past few years. And the operator-led community that leads ONF said, hey, we've got to get this out of the lab and into the field. All right, so let's rather than stretching ourselves across too many projects, let's focus on a few that we can define a more detailed reference design around, and let's get some momentum around those so that we can get those in the field between 2018 and 2019. And so those were the kind of four we mentioned earlier. We'll go into more detail of those. So those became the four in focus for now, and then there's some trailblazing activities beyond that. But ultimately the main goal was this can't just be a POC anymore. That's great and all, and showing disaggregation and those concepts. And I think a lot of operators believe in it, but they really need, from a blueprint, needs to be more than just, PowerPoint slides and maybe some rudimentary software. It needs to be more the deployment grade software that every operator can build upon. So anyway, that was kind of a renewed focus earlier this year. The whole Cord architecture is built around the idea of you have a lot of components. There's both infrastructure components, white boxes, virtual network functions, and different software stacks, whether that's Volta, ONOS, XOS. There's a new one called NIM that's part of C, but we'll get into these a little bit later. Trellis, all of these are different software applications. And so you basically take a mix of the access technology or the transport technology, you pair that up with a set of these software platforms, those create a reference design. So the combination of a mix of software platforms. Now these software platforms, and I'll show you in a diagram that hopefully will make it a little more easier to understand. These software platforms like ONOS, for example, get reused across a lot of reference designs. So there is some reuse, and it helps when you talk about driving convergence and stuff. But we'll get into that. So you take those components. So in that last slide, I showed different software platforms like ONOS and Volta. You take those components, you build up a reference design, as I just noted. And that reference design being, okay, these software platforms with these specific set of software applications paired with this disaggregated hardware creates a reference design. The reference design, you think of that's like the blueprint for all things SDN-enabled broadband or transport or whatever. And then you'll have variations of that. Each operator, hopefully wouldn't be a lot of tweaking, but every operator would have some customization, adaptation to fit in their network because they need to tie it into their OSS environment. They have a different set of needs. And so ultimately those different reference designs, so maybe like a DT is an operator that looking at CEBA, maybe there's a DT exemplar for a CEBA reference design. There could be an AT&T exemplar. So exemplar referring to an example of that reference design. Now they would hopefully use 80% common and then maybe a little bit that's unique to their network adaptation. So those exemplars would then be taken into the production process. Along the way, if you were here yesterday when like DT spoke about Access 4.0, which is a good industry example for a CEBA system, they said, hey, we thought going in, maybe we could do some of this on our own and hire our own developers, and reality set in, and yes, they need help, right? And so there will be solutions integration partners needed to make this. That's where companies like ADTRAN that specialize in these types of solutions and others in the supply chain community kind of help the operators in making these deployable and something that you can actually stand behind in the field. So that's kind of the high-level deployment model. Andrea kind of touched on this in the last slide, so I won't repeat this too much. But there's four reference designs that are in focus in the near term as far as making deployment grade, and then there's a couple of others that are more in what you'd call the trailblazing activities, like, beyond not expected to be a GA product in 2019 necessarily. Some of them include a lot of hardware, some are mainly just software centric. So like UPAN is an example of protocols like P4 runtime for data plane programmability in lieu of OpenFlow. It includes things like gRPC for telemetry and other more modern software applications. And so that would be an example of like a software suite that's also a reference design. So it's not necessarily all just hardware. So let's see how we stitch all this together. Hopefully the slide's going to get busy. It starts out small, but it's going to get pretty busy, but hopefully it'll show you some of the value of these reference designs, and when you stitch them all together, it can help drive convergence and kind of provide a good blueprint for a next-gen network. So Any access aggregation network is going to start with a leaf spine fabric type of aggregation architecture, most likely. And if you wanted to start there, what ONF reference design allows you is you can take white box disaggregated hardware, and there's actually not only the hardware specs that are out there, and there's multiple options here, but it provides, here's an SDN controller that runs all the real intelligent logic in the controller as applications on the controller, so it runs in the cloud. So you'd typically have an edge cloud. So imagine a central office type environment where now you have edge compute infrastructure in place. This is just control plane software only, so data plane's still all in hardware. But inside that control plane software, you have an SDN controller, and all the exception traffic, all the control plane traffic, like routing tables, BGP, all those things, they're running in that controller. And it's programming this leaf spine fabric through OpenFlow today. And then I'll talk about a little bit later where Stratum will evolve that even further. So you get hardware, software, everything, and there's a big operator already deploying this in their production network this year, right? So you get production grade software, everything out of the gate. So obviously the potential cost savings for, these aggregation switches are typically 48 by 10 gig switches and 32 by 100 spines. So you get really high density 10 gig aggregation at a fraction of the cost of maybe a traditional solution. So then if you want to do access, broadband access, fiber access, like GPON, XGS-PON, GFast, any of these other technologies, then there's a reference design for that. So it ties into the fabric switch if you want to. It's optional. You could use an existing BNG or whatever as your aggregation network, but you can pair these two together. They are independent reference designs. On this reference design, you have the disaggregated OLTs. Introduces a new software platform called Volta. It's there for its virtual OLT hardware abstraction layer, although it's now extensible to technologies other than PON. But that's where it started out. Its main goal is, let's take control plane software that used to be embedded down in the OLT hardware and let's move it up here. And let's make it just a generic abstraction layer into the bottom side of the SDN controller, so that the SDN controller thinks that it's programming an OpenFlow switch just like these guys. So it's effectively trying to make this OLT and ONU combination that's on the end look like just an Ethernet switch is the goal. And it also takes stacks like OMCI and it runs it in Volta. So the ONU interoperability and stuff is no longer very dependent on the OLT itself. It actually runs in the cloud environment. So that's what you get with CEBA. And so when we talk about SDN-enabled broadband access, it's this. It used to be people that knew the term RCord. This is effectively the same thing. It's just effectively a new name for the reference design that was usually referred to as RCord. It also introduces a platform at the top that's called this Network Edge Mediator, NIM, and you'll see that terminology now. That's relatively new over the last 6 months or so. That's come about as part of the CEBA reference design. Now, this is basically providing operational tools and abstraction of the overall pod infrastructure. So make this OLT, try to make this disaggregated OLT tie into your existing OSS stuff. Like it's more like a domain orchestrator. Well, I should say, I wouldn't call it a complete domain orchestrator. It's a set of EMS operational tools and some abstraction layer so that, the global orchestrators and stuff like that, or the existing ITOSS systems don't have to deal with all these complex disaggregated items when they're monitoring and provisioning them. And so NIM would also typically reside, everything I show here typically resides within the pod. Like if you saw like the DTA4, they had a physical pod with OLTs and fabric switches. Everything you show here goes in that pod. And NIM, the software platforms, NIM, ONOS, Volta, all those would run on that pod and compute that lives within that pod. And then if you want to then interconnect pods together from one office site to another site, this is where the transport, optical disaggregated transport network reference design comes in. Same controller, new set of apps that they'll cover in the next one of the next presentations the NTT team will do. And it'll cover monitoring, programming, both the transponders and the open line systems for the transport component. And so then lastly, not last, then there's these trailblazing activities around edge compute infrastructure and mobility, so MCORD. And so Now you're starting to even combine in, mobile access. Again, this is the one that's in the trailblazing category. So this is another a little bit further out in time, but it's already there was a proof of concept demo of this at Mobile World Congress Americas just a month ago, and so it's progressing along pretty well. But this now provides you a complete blueprint, as you can see, for everything from aggregation, fixed access, mobile access, X-haul, transport, everything under a common blueprint. So, and most of the software that you need to operationalize this, and it'll come over stages. It's not all out of the gate day one, but it's in the open source community. So it's being contributed back. And so when operators adopt this, they actually contribute it back. An example of those contributions and continual innovation is things like Stratum. Now, Stratum covers things like what we a lot of times call SDN++ or next-gen SDN. It's basically this protocol suite like P4 runtime and gRPC network management interface that are used to basically monitor, manage, do real-time telemetry and programmability of these devices. So you can have a Stratum plugin for the north side of Volta. You can use a Stratum plugin for these leaf spine switches, so that this basically expands. OpenFlow is great, but has some restrictions in terms of the flexibility of the table type patterns and other things that you can program. P4 runtime provides more flexibility in terms of, one, the types of switches, the hardware vendors and stuff that you can use in these fabric switches, but also the types of data plane programming rule sets and stuff that you're applying. And so anyway, the point is that you've got members like Google, leading edge cloud guys out developing software, contributing this back. You've got AT&T contributing back, DT, NTT, Comcast, all these guys, both adopting these platforms, contributing back. So now you have a pretty good baseline in which you can kind of build your next generation converged network around. Then on the top side, you'll have eventually ONAP, and there is actually an open source access manager kind of piece that I've kind of blended in with NIM for now that can use to kind of connect between ONAP and these systems. Now you can also tie those back into your existing I2SS, so it doesn't have to be a forklift upgrade. It doesn't have to be, well, I have to adopt everything or nothing. I mean, no, you can take bits and pieces. You can just do CEBA, keep your current BNGs, keep your everything else the same, and just use CEBA. You can just use the fabric switches and to aggregate your existing network elements. So it is a mix and match, but if you're looking for, in our industry, if you're saying, hey, what's the closest thing to a blueprint of here's how you should build your next gen web scale network, we think this would be it. And we think this will be the continual innovation, the crowdsourcing, and everything else that these type of reference designs enable will make it very attractive. Now, obviously, there's a lot of investment on the front end to get these things across the line and into the field. You will have to change, the business models will change a bit. You'll work with solutions partners to kind of help get these where you used to maybe get everything from a turnkey system integrator. That whole relationship's going to change a bit. But there's obviously a tremendous amount of benefit once you get these across the line. So the ecosystem is basically, as I've kind of verbalized, there's operators that adopt these platforms. They contribute, I guess I should step back. So the ONF itself is a not-for-profit group that has funding from operators, vendors, others in the ecosystem, and they have their own software developers on staff that support and maintain a lot of the software that I just showed on this chart before. Helping that is the operator group that also contributes developers, architects, others to testers to help build out the system. Then there's supply chain partners, similar to ADTRAN, that help also with contributing software, designers, everything else, testers. So the combination of all that creates a pretty sustainable ecosystem of test and development resources to bring these products, these reference designs to market, and then help the operators through the whole process of making it, I would call, commercial grade solutions. The supply chain partner, as I mentioned, they will play a big role, because they may ask, well, why would someone like ADTRAN get involved? It's to help operators make these deployment grade. So that's kind of where we fit in the supply chain from an ADTRAN perspective, but obviously it's just one role of many that take place in getting these products to market. It's not just ADTRAN. You see the names here of the different supply chain partners that make up the ecosystem. Last slide, just kind of a summary. Now, what is it why would you adopt these reference design? Most of it's probably fairly intuitive, but ultimately there is lower OpEx and CapEx than closed vendor specific systems. Mainly that's because the solutions are fully automated by nature. The solution is extremely modular, so a lot of the intelligence being centralized in the open source software platforms allows the networking elements to be more interchangeable parts. It's disaggregated by nature, and so you basically don't have that vendor lock-in scenarios of the past. And because you're reusing a bunch of open source software as the baseline, any additional modifications or customizations for that individual operator tend to be smaller in nature, and so software licensing and other things tend to be much lower. It is faster time to market for new services based on the inherent programmability and the community that's out there building applications around this. It will foster kind of innovation and bringing new products and services to market faster. Crowdsourcing and continuous innovation is a big deal, right? I kind of mentioned like, hey, the Google bringing all the work they're doing in Stratum to the contributing that back to the open source community. That kind of ongoing continuous innovation, something you just don't get in the traditional closed ecosystem approaches. So you don't get that open community engagement and development, and that's what you kind of we're ultimately trying to achieve with these open reference designs. And then, it is more adaptable because a lot of the centralized intelligence approach, where a lot of the control plane applications are running in the cloud, it really makes the networking functions a little simpler. And so once you have the ecosystem up and in place, so adapting to new fabric switches is much more straightforward as long as the control plane is centralized and not embedded into the OS that runs on the devices. And then last one, it kind of facilitates that convergence. I showed enterprise, residential, XHAL connectivity all on a common blueprint. So this kind of gives you a way to, if you're trying to drive convergence and streamline operations, a lot of big operators are looking for ways to, streamline their organizations. This is a way that you bring all those people together. I think people like DT talked about that. It's a lot about reorganizational alignment. And so this provides a path, a kind of a blueprint for them to follow, like, hey, let's converge all these operations together. Let's follow some of these blueprints. And we build out our next-gen networks. So that was it. If there's any questions, I have a couple minutes or either one. Okay, so Drea, who's next?
Okay. No, I have
this.
mine.
Yep, thanks.